All right, and we're live. Hey, my name's Robert Taylor. I'm an engineer here at Outpost Games, and I do. What do I do here? Okay,
I asked you that earlier, I think.
I told him I was a bit fiddler.
I don't know what that means, but
It means I fiddle bits. Computer's made of bits. I do a lot of things, but today I'm going to be focusing on showing you kind of a rendering technique that we've added to Unreal Engine. They've got an incredible engine. They've got this really neat material system where anyone, without having a deep technical knowledge, can go in and start building whatever shaders they want by wiring things together and getting outputs to different buffers. So it's really neat. And today I'll be showing you how we've created custom velocity rendering. So basically, we pretend that these pixels are moving in space, and it allows like motion blur to operate on them to make some pretty neat effects. And so this is kind of our in-game world, and it's showing on the left the technique being used, custom velocity rendering from the waterfall. And then to the right, it's not a completely fair comparison because there's some dithering going on, but you can see that it doesn't have that same kind of volume and movement that you see on the left. So today I'm actually going to be not showing you how I did this in SOS. I've got a fresh copy of Unreal Engine 4. This is crazy of me, but I'm actually going to start building it all from the ground up, or nearly from the ground up. I've got some header files that I don't want to waste 2 hours of your time just compiling. And I'm going to show you how you can also create this type of effect. So I'm using Unreal Engine 15. And one thing that kind of threw me a little bit, it won't make a big difference, but they changed how motion blur has worked, I think, between 4.13 and 4.14, or 4.12 and 4.13. We use 4.12.5 here at Outpost. And so it'll look a little different, and I have to maybe adapt to it, but I'm really excited to kind of dig into some engine level code for the Twitch community and for Outpost community, and also the subreddit game dev. If anyone is from there, thanks for tuning in. It means a lot. So without further ado, let's get rid of our game and let's show you the final code. Can you tell me if this is a good size, or if I need to somehow increase the size, Micah? On the stream. Yeah.
Seconds.
Darn, the delay is going to make this a little difficult, but we'll figure it out.
Funny. I think it looks okay.
Looks okay. You can read it. Switch to 1080p and maybe get off a phone if you need to see it. This is going to be very code heavy, so I'm assuming that you know a basic understanding of C++, some HLSL, which is the shader language, and a basic understanding of rendering. But if you're an engineer and you have questions about kind of the rendering pipeline, those might be good questions for me to answer. And for everybody else who's more of like a gamer, I'm hoping you get some value in this. Maybe Micah will give me a beer or two. We'll make this a little more exciting for everybody. So the first thing I'm actually going to do is just blast away all these changes. So these are all the files that end up needing to be modified to create this effect in Bobby Trouble in the house. Yeah. Good to see you, Corland. We're going to get rid of everything but the header files. And the reason I'm doing this is because if I modified those header files, or if I made the changes while we were building this technique out, we would be sitting here for days, because like, the easiest way that I can describe a header file is like it's a contract between two pieces of code. And if you break that contract, imagine it being like you have to renegotiate your salary or something like that. So let's get rid of all the shader files, the C++ files, and then let's get rid of this. It'll take a few seconds. I don't know if it's making authentication failed. That's not a great sign. Repository not found. We'll see what happens here. All right. I basically got rid of nothing there. 1 second. Let me figure out what is going on. Maybe I have to unstage him first? Yeah, maybe. Come on. Worst case, I've got another branch here This is, I'm used to using Perforce here at Outpost Games, so right now, oh, there we go. So it's unstaged. Now let's revert.
Thanks for the host, Unreal.
Thanks for the host on, oh man, Unreal Engine. That's gonna be embarrassing
and
for me.
Thanks for joining us, everyone, from that host.
Absolutely. Thanks. Who's hosting it? Yeah. Okay, sweet. Oh, Katie Rue, thanks as well. One of our favorite players. All right.
We're gonna get a raid here.
So, like I was saying, now that Unreal Engine is tuning in, just getting rid of all of the changes that I made to vanilla Unreal Engine 4.15, so that I can make those changes once again, and we can kind of make incremental progress to the waterfalls that you were seeing early on in the stream. So once these are discarded, there we go. Okay, perfect. So we're going to actually start to compile this. It's going to fail. But I wanted to get the ball rolling on that. So if I press compile and run, this is going to go for a bit. I'm going to put it to the side, and we're going to look at the header changes that were made. So there are a couple of things that need to be done for this custom velocity rendering to work, especially for our use case, where I'll give you the full story of how we started to come up with this technique. It was... the people that were here at the beginning of the stream could see kind of the waterfall on the right had some ghosting from something called temporal anti-aliasing, where it's like it's moving along and then it's got a histogram of where it was in previous frames, and it kind of fades out. And Jake, my technical artist, amazing technical artist, came to me and said, like, how do we fix this ghosting? And I was like, that's a really interesting question, because they actually have like anti-ghosting inside of their own post-processing shaders for temporal. And they handle it using the velocity buffer, which is this buffer that fills the entire screen. Every single pixel's got an entry, and it says where are things moving? How fast are they moving? And so it's able to then use that to correct. And so I thought, well, if there's a way to handle moving pixels, so if you've got materials, you've got UV scrolling for things like rivers and waterfalls, where the verts, the geometry itself, isn't actually moving in 3D space, but the pixels themselves are. So we thought, well, let's try to, in the material, we know how fast it's scrolling along the UV space, and we can project that into screen space, and then from there we'd be able to figure out what the velocity is in screen space, and then output our own velocity to these materials, so that potentially the ghosting disappears and we can use motion blur. And actually, when we started this experiment, I didn't think it was going to be. I think it turned out better than I'd hoped. So if you're patient, you stick around for the full 2 hours. Hopefully by the end of it, we have it working again in Unreal Engine 4.15.
Thanks for the host, the only Ryan.
Hey, thanks for the host, the only Ryan.
A little late on our part, but and
thanks for the follow, Hanson. This is why Mike is here, because I'm going to be I've got code vision and code tunnel vision, so it's good. It's failed, actually, the build to the left as expected, but I wanted to go over the header files first. So the first change that's made, this can't be, there we go. The first change that was made is something similar to what the skeletal mesh components have, which is basically a flag that allows us to mark any static mesh as something that will be rendering to the velocity buffer. Because normally when you move, if you've got a static mesh and it moves in 3D space across the camera, it will trigger it as like, oh, this object is now dynamic, static mesh dynamic. It will start to output to the velocity buffer, but it will use basically just the verts moving through 3D space. So we basically wanted a way to always output to that velocity buffer. So first thing we do is we expose always has velocity to the components interface, which allows people, designers and technical artists and artists, to go in and put in their own things that are like waterfalls and check this box that says always has velocity. And now there are better ways of doing this, but for the sake of brevity and the fact that I only have 2 hours, I'm going to be making some shortcuts to get us where we need to be. So if you can also see, I've got this if1 begin outpost and end outpost. This is how you can tell I do it for multiple reasons. The main reason is right now it makes it very easy for you all to see the code that I'm adding to Unreal Engine versus all the other stuff, which is the code that was already built by the much better engineers over at Epic Games. It also helps with poor Brad, one of our other architects here, who has to handle most of our merges because he goes, what did you change in this file? And if it's got these nice if one begin outpost else, and then you put the Unreal Engine code and then end if, it allows him a much easier time with resolving conflicts. So that's all that exists in static mesh component, that flag that says, I'm a waterfall or I am a river, and I'm always going to be outputting velocity. So mark me as dynamic all the time. In addition to this, we've got the other ones are all related. So it sucks that I have to keep the headers in this state before, instead of doing it kind of incrementally step by step, because if I got, like I said earlier, if I got rid of these header files, we'd be here for hours compiling. So I'll try to briefly explain what each of these are, but then the process of like implementing them will be done in a more linear way and in depth into actual C++ files. So the first thing that we added, so once we decide that this object, this waterfall, will always be rendering to the velocity buffer, we wanted a way to say, hey, when it renders to the velocity buffer and when it creates a material policy, a drawing policy for velocity, we want it to use basically code or material nodes that our technical artist has created. So to do that, I thought we could have used some of kind of like the custom UVs and existing pins, but that's kind of boring. I thought it'd be really neat to kind of dive in and add our own pin for velocity. So right here, this U property velocity, F vector 2 material input velocity. This means we're going to take a vector of two components, X and Y, for basically U and V of the screen space, and take that as the velocity input. So this basically exposes a pin in that material system. This is material.h. It's one of their biggest files in the material engine. And that's the first step. Second step, went in, and this is related. This is expression input. So this actually is the pin, I believe. So we added one right after pixel depth offset, velocity, which we will map to the material input velocity. And then, luckily these are pretty small changes here, so the bulk of it will be in the CPP files. Let's go to the other one first. Scene types. This is the material property for kind of how it handles actually making the connection from, oh, this is an input to this pin, and then we need to output HLSL to our material template. What's the basically tag that is used to represent this data? And it's MP velocity, again, right after MP pixel depth offset. Hopefully I'm not losing anybody yet. So those are most of the changes. And then the other header file, I don't know why all this is actually in a header file. I'm sure it's for inlining reasons and making it faster. But in here, this is translating. This says, all right, let's take all of these nodes and store it inside of these. Set up these chunks that are going to be handling the output from material nodes to HLSL output. So those ones, actually there's one more change here. Let me go to the next one. Here's where it actually prints it out to the HLSL file, the shader file. It will generate function code for that velocity material identifier, and we output it right after we output the area for custom UV assignment. So at some point, once I've got, oh, is it still compiling? Hold on, let's look at this. Okay, so looks like it's taking a bit longer than I thought to compile, but we can go over and fix all of the issues as we go on. So the first thing that will happen is when you've added that new material input, that new material property. I'll keep this up actually. It's going to complain. It's got a really good safeguard here to capture all of the locations where you need to handle cleanup or serialization and all that information. It's got these static asserts. It says, make sure that the max is 29. I've just incremented it to 30. So now I have to go through to each one of these asserts and and do the custom logic for velocity. So here we go. This is for compiling. So we're going to need, right after pixel depth offset, first of all, we'll do this. Now we're going to be in, ooh, that was a bad typo. Begin outpost, else, and if, and outpost. Hopefully that doesn't take too much time for me to do that every time. We're going to increment that to 30. So now that we've got this new material property, it's incremented the length of that enum. And now we're going to need to add compilation for our new expression, which is velocity. We're going to do that. And no, hold on, forgot this. And let's do the same thing, just in case somebody tunes in late, to know what we're adding. Okay, I think that's the first step. Let's see if there's anything else needed in the compilation step. No, I don't think so. I think we're good. Same thing here for break material attributes. So this is for when you've got the there's basically two ways of inputting material attributes. You can send it all as one kind of structure, and then of course you can break it out and then assign pins individually. So this handles, does it default values of these outputs? Let me see what it says. Yeah, it looks like it's a mask. So I'm just gonna use the masks that they've used before. They all look the same to me. I'm also going to try to do as little compilation as possible throughout this and try to do it in chunks so they don't have us sitting here, because like even right now it's stuck on linking one file, so it might actually be in a weird state, but might as well do some work while it's spinning its wheels. So we've increased it to 30, and then actually make sure, I'm assuming they should be in the right order. So pixel depth is offset, velocity. This is good, that looks right. Nothing unique for the fact that it's 2 components instead of 4. Let's see what else. Another assert. 1. Okay, so this area right here is serializing out. And this is where you would handle any type of fixing up between versions, like if you've made a mistake, like I do all the time, of what gets kind of written out to disk for these materials. For velocity, we don't actually need to do anything like that. We're gonna be fine just doing the default. So we don't need to track whether or not, like, what are some examples that need expression flipped? Need coordinates checks, need comment fix. Like here they changed one of the blend modes on every material that got written out. Yeah, it's serialized out. So bring this to 30. Are people getting this, Micah, or am I?
They're having a great time in chat.
Do they? All right, well.
You keep going. We've got.
All right, we'll keep on going. This is
I'm
good.
sure
So
there's
still
a lot of people watching who aren't chatting right now. So.
Good. All right. So we've handled so far all of the asserts that have popped up in compilation right now. Hopefully the other ones will happen quickly. Has it been hanging on 11 out of 18 for a while? Let's try. This could kill me, but let's see. Cancel. Let's start up again. Make sure I don't have anything running in the background. All right. Let's see how you fare, buddy. Has the did the viewer count go down as soon as I started getting into code? Is that?
No, it went up.
No way.
Yeah.
Oh, I don't believe you.
Went up by 8.
A whole 8. That's good. That's certainly not just The Office.
No. They were already
Just
watching.
teasing.
So.
All right. Why is it taking so long? Maybe I'm just being impatient. 2:20. Okay. We're making okay time. I guess while this is going on, let me make sure. Not like... Alright, it's doing something. Unreal build tools running. Seems low usage for Visual Studio. It's doing something. All right, let's move on to, well, let's maybe anticipate some of the other other asserts we'll hit. So actually, I may have hit all the asserts, and it might just be actual implementation we need to handle now. So first thing we're going to look at, this is an easy way of checking all USF files, which I assume stands for Unreal Shader File, Unified Shader File. I don't know. It's cool though; those are cool. Well, one thing that will crash on us when we start to play is material template. So if we go, oh, this thing is the mother load. So this is essentially the blueprint, not to be confused with Unreal Engine blueprints. Actually, let's go back because oh no, those are correct. Okay, so we've got the 3 asserts, and we're still compiling. Okay, so it's actually making progress. Yeah, let's look at the material template and understand kind of what it's doing. So what's interesting is you'll see all these %S's. That's because this is actually a giant string, and it's going to use the famous C printf to insert code throughout this material template, and it creates one for every single one of those materials that you create, base material, product material instances, and then it injects into each of these things what you've put into those pins. So you've got one for opacity, mask. Oh wait, actually, also some of the settings that you have on the left. Let's look for one that's actually a pin. So get material world displacement. It grabs half-3, so 3 16-bit components. Get material max displacement. Some of them are shared. Okay, custom data, just returning half. And some use shared, so they actually compute it, I think, up here into the G buffer. See texture lookup? Well, it's somewhere, but they basically go, oh, the dot normal equals, and then it's calculated once and then can be reused. And for our use case, velocity, I don't think it would need to be shared elsewhere outside of the velocity shader. So this is what will be generated, and somewhere along the bottom actually in the velocity shader, we're going to calculate it per vertex. We're going to call one of these template functions that exists and says, all right, well, grab all the code that's in this function that's returning from this function, and use that as, oh, cool. So it's compiling now. But it's going to compile and it's going to crash and burn. Watch this. So it'll try to, you saw that print in, I forget where it was, in here? No. Yes. Compile? Nope. It was, well, we'll find out in a second once it craps out on us. But that'll be good. That'll show us that we need to update the material template. All right. Look at that go. And well, it hasn't crashed yet, but it will, trust me. And actually, if it didn't, it means I've accidentally skipped a step. All right, maybe I'll use this as time to talk to the chat. Anyone got any questions? What's a computer's favorite snack? A microchip. That's pretty good. That is pretty good.
Yeah, they're being super entertaining and shy.
Good. Somebody has to.
Oh, and Jake's here. Nice.
Jake, how's it going? There's my favorite tech artist. He's the one that really made the waterfall pretty.
Damn. More new viewers.
Oh my gosh. New viewers? There we go. Okay, good.
Nice.
This is what I expected. So it's failing an assertion. Let's go. Why did it open that file? No. Here we go. Where's my mouse? Why aren't you? Does it stop clicking? It's not liking me pressing anything on this window. Let's give it a second. See if maybe...
Oh, here's a question.
Okay, what's that?
Will shader complexity buffer show the complexity of this shader?
It will not. I don't think so.
That was from Perfect Nuke. Thanks for the question, Perfect Nuke.
I'd have to look at how... Okay, there we go. I would have to look at how
Wait, we got another question for you.
Okay, what's up?
Ian Cofino asks...
What did Ian ask?
At what time did you say you were popping that shirt off?
Hey, what ain't that gonna bad? It's not weird. Actually, it was hilarious. Is the background in this were pretty much being registered as green, and so I looked like I was a floating head. All right, so where did the 14147? Why didn't it? Oh, there it is. So it's failing here. Did I miss a break? Oh, yeah. Okay. So this is great. This is capturing many of the different places we need to clean up. So what I'm actually going to do is use pixel depth offset as kind of a locator for all of the changes that need to be made, because there's a lot. I should probably make like a checklist somewhere to allow for easier addition of material properties. But for now,
Omar asks,
what's up, Omar?
I might have missed this. Is the material template just C++ that's getting glued together?
No. So the material template is, it says USF, but it's actually, it's HLSL. It is, it's literally like a C++ string that is like the text itself is HLSL, and then it gets filled in by, it says right here actually, it gets filled in by get material shader code for each material being compiled. So all those %S's, like when you think of printf, and then %S, and then comma, whatever the string is, it will literally print, it will use material template in a printf with all of the other compiled shaders. Sorry, not compiled shaders, with all of the output from the materials. So whatever they're compiling. All right, so we don't care about any of these USF files. Maybe I should have stayed in C++ land. All right. We're going to make that same check again for, what was it we're going to use? Displacement? Pixel depth off? Yeah, pixel depth offset will be, because it's used the least. And let's look in. All right. Bye-bye, Ryan. Okay. So in the editor, get on promote to perimeter class. I think, okay, so because our property will be, is this? Yeah, it's not going to be a scalar, it's going to be a vector. Therefore, we're going to put it in here. I wish there was a cleaner place to put it. Maybe I should just put that in copy paste somewhere. NP velocity. Okay, so there's one change. I wish it was a little more like sequential, the steps that I'm taking, but hopefully, like, if we archive the video, you can piece things together. Okay, neat. So here is we're rebuilding the material graph. It's actually adding to the inputs. So let's keep everything in the same order. Material inputs, velocity, NP velocity. As you can see, this was I felt like a good rendering kind of stream to do, because it's fairly simple. It's not most of what I'll be doing for the first like 30 minutes to an hour is going to be cookie cutter. Epic has basically already paved the way for a lot of this. It will only get exciting if I make mistakes, then have to debug it. Okay, I made a mistake there. This allows us to have, when you hover over that velocity pin, what it's going to say. It'd be like, velocity dash reindeer, woo! No, we're not going to do that. I've already added to the material header. Don't want to touch that file again. Already added it to the expression inputs. Don't want to add that again. We don't need to just serialize data. Let me see. Okay, this could be used if you saw earlier where I was putting that Boolean onto the static mesh to say, hey, this thing's always rendering to the velocity buffer. You could simply have a parameter here that says B uses velocity input or something. And then from there, you'd be able to automatically turn dynamic velocity rendering off and on without having to manually modify it. But I just don't have time to do that, so we're going to just barrel on ahead. So skipping that. Going to skip this. It's not relevant. Shared pixel properties. So I don't believe we want to share this pixel property. So I'm not going to add it as a shared pixel property. Plus, it's not going to be a pixel property. It's going to be actually on the vertex shaders where it'll be able to be accessed. So skipping that. That actually makes me think I should have used a different version. So let's do customized UVs instead. That's actually a good idea. Because these are per vertex for sure. Thanks for the follow, everybody. All right.
I caught it, but I didn't see his name, and I was like, oh, whatever. Heather, I'll do it.
All right. So these are setting default values. What function? I haven't touched this code in a while. Helper for compile properties and set material property. This one we may have to cowboy code. Compile property and set material property without cast. Let me look at the logic. So it's for emissive. Is this for like lighting builds or something? Light mass. Okay, so these might be. These are looking like default values, so I think it's safe for us to probably always output 0 for all of our, for any of these ones that look like they're, if any of them look like they're returning default values, it's important for us to not be returning default velocities that aren't 0, or we're going to have really, really blurry screens, more blurry than temporal normally is. So if it's velocity, let's return a constant 0. I don't think it matters that it's a vector. I think it handles both. Yeah, takes it. What does it take? Int? Interesting. Okay. So constant of 0. Let's go with that. Have I missed anything there? I don't believe so. This is compile property and set material. This seems very similar to the other one. What was the other one called? Compile property and set material property without cast. Compile property and set material property. Okay, so similar things. So let's do the same. We're going to output 0 if it's the velocity property. And just for my sanity, do this. All right, I think we might be done for the material editor. Okay, so that might be, I wonder if that's, yeah, that actually might be showing the default property when you've got the material kind of viewport up in the top left, if I'm remembering correctly. So this is customized details. This is not needed. This is not actually relevant to what I'm doing. This is visible pin. Actually, we want it always visible, so let's make sure. Okay, we'll let UI material handle it. If the property is material attributes, don't show it. Okay, it's going to show it. That's good. And this is visible pin. Oh, is that the same one? Yeah. So I think we're done with material graph. Light mass render. Okay, this is probably important for us to. Yeah, this looks like it's also default value. So in here, we're going to want to do the same thing. Sorry if this is tedious. That's what a lot of coding is. It's good to learn that now. Oops. I'm actually so nervous that my hands are shaking and it's making it harder to type. Give me a beer.
Usually we're only half an hour in, maybe at the 45-minute mark.
Oh shit. Okay. So it looks correct. Material graph. Okay, this looks like something we've already done. Yeah. This is where it was asserting. No. That's good. We're done with material graph. Okay, not touching header files, like I said. That's going to be crazy. We're getting close. Maybe halfway through the needed CPP files. Post load. Do material. Okay, this is really important. Actually, I'm surprised it didn't complain about this. This is super important. So if you don't do this step, I think they've got warnings all over the place that you're going to basically, you're going to have out of order issues once you upgrade versions of Unreal. All right, so let's do velocity. I probably should, do we bump this? Nah, I think it'll track it itself. If anyone is here from Unreal Engine, that would be a good question for you to answer if I need to do anything unique about the Unreal Engine version, or if I'm already screwed by breaking away from trunk like this.
Interesting.
It's worth it though. All right. So that's what we need there. This is good. Okay, this is good. This does the mapping from these inputs that we had to those identifiers that we were looking at, or properties, what they're called. So we want it here.
The Weasel God asked, does this end up getting incorporated into blueprints at all?
It will. It'll be incorporated into, yes, and more specifically, it will be kind of material system.
Jake just disagreed with you.
Well, material editor I
Yeah,
consider.
Yeah,
and you can drive you would be able to drive it through a blueprint. So yeah. Yes, Jake. Yeah, you just make some material parameters and then wire them up to the velocity pin. Okay, so I think we're getting close. This was one of the most important ones. I'm surprised it didn't assert on this. I would have asserted on that. Compile property. I think no, this is where it was failing. Okay, so good. So once we fix this, we are going to be, it's going to be good. So I'd say half of what I'm coding right now is the words begin and end and outpost. All right, MP velocity. This is where it's compiling. Actually curious what it means by compiling. Is it outputting HLSL at this point? What's it returning? Nope, compile default. We're gonna go down a rabbit hole for a second just for my own curiosity. Forecast, compile default expression. Okay, here. Compile default property. Where does it grab the property? Interesting. Okay. Where was I? Let's go back in here. That's the same function. Don't need this anymore. Are we almost done with material? I think we are. I think this is the last. Oh, no. I was a liar. There's two more. Is property active? Okay, so this one, we might as well always have it active because it's not a, we're not going to make it a shared property. We're going to make it a non-shared. We're going to make it a selfish input. So let's make it always show. If it's decal, it's not a decal for us. If it's domain is UI, we're not going to care about UI for now. Where is it check for everything? Okay, so it's going to then check the rest. Here's where it's checking the material property And where is depth? Pixel depth offset. Let's do it in here. Actually, it would already be outputting true, but just in case.
Other Rob's pretty hilarious.
What did she say?
Rob Weiss.
Oh yeah, that guy is. Honk honk. Can you get your? Let's get your. What's that? The clown horn.
Oh yeah.
So hilarious. Okay, so that's good. That'll have it so you can actually put something into that pin. Otherwise, it might be grayed out. And then, okay, I don't care about UI for now. Can't think of a use case where you'd want motion blur on the UI, and I think motion blur would absolutely happen before the UI is rendered, so let's just skip that. Already got this one. This is make material attributes. We must be getting close to the end here. Thought I already added this one. Uh-oh. Which one did I think that I added? Oh, I did. I just didn't do this. I'm a fool. That's why it's important for me to do that. I'll never know if it's mine or not if I don't do this. All right, where do I define how many components it uses and precision and stuff? This is good. All right. Okay, this is where we make sure to use the right index. This is where things probably would make for a messy merge with Epic's more recent versions. So I would recommend being very careful before following my lead on this one, unless you're willing to clean up all your materials. Property to IO, yeah, okay. Let's do 25.
Epic Arn says something.
What did he
that
say?
might be helpful there towards the bottom. I don't.
There is that to not get screwed over, the version is licensed. Okay, so are you saying I should replace the get UE4 version with get linker licensee? If he responds, let
It'll
me.
be 30 seconds. But
Okay. I might not worry about that right now, but
yeah.
I'm gonna reach out to him. That would help.
Thanks, Epic Arn, and let us know.
You're the best, Epic. I'm also sorry for like butchering your code live on your own channel.
He says yes.
All right, sweet. I'll do that later if I remember, just so because I'm in the zone on these.
Yeah.
On this boilerplate. Boilerplate. Okay. We don't need a number of velocity buffers. Okay, this will be fun. Gotta generate a GUID, I guess. We're gonna add. Where are the? Let's consider it advanced. F vector, vertex, vertex. We're gonna put our own somewhere here. So this looks like it would also help with bad merges when, as long as you're using a unique GUID. All right, so a few things we need to change here. We're gonna have to change this for sure. We're also gonna need to reference our velocity. It's gonna be float 2 for now. What's interesting is you could, I've been thinking about it, make it a float 4, and then there's something I do later on where you're gonna hate me for this, but I'm gonna double the size of the velocity buffer. Because I want to basically apply motion blur, but not temporal. I don't want temporal anti-aliasing to think that the pixels are moving as fast as they are. So I kind of like split them and allow basically custom velocity just for motion blur. And for that, like using a float 4 might make sense in that case. But for now, it's just a float 2. And then is this a mask or default? It must be default. Let me see. So it's going to be in the vertex shader. Let me look into what it's an attribute map. No, it's a, yeah, it is, okay. Where's that? Shader frequency, interesting, okay.
Thanks for the follow, Bob.
Thanks for yeah, it's default value. Okay, cool. So we want default value to always be 0. And now we need to create a GUID, which for now I will... Shit, okay. You're going to... I'm torn between wasting a lot of time and making a really shitty shortcut. But I'll do it properly. I've got time. It's only 2:46, actually. It's a 2-hour stream, right?
Yep.
Let's...
Got an hour.
Generator. What do I want? I want a good... How many bytes that? 1, 2, 3, 4, 5, 6, 7, 8, 16, 24, 32. 32 bits. Just 32? 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. This'll work, actually. Okay.
You want that beer?
I would love a beer. That'd be great. I could use a beer. I do my best work when I'm...
okay. Well, we know.
6 C D 0 0 B 3. Make sure I'm not typing anything that isn't a hex value in here. If I misspell something, that's not the end of the world. But A4 C4. Thanks for the follow, Methyl. See, I can say thank you when I don't have Micah. AC4. Did I just leave it in place? No. EA 0. I should have just copied and pasted it, but whatever. C4. Oh. All right, that looks like it will work. Okay. Make sure I didn't miss something. Make sure to read. I want to see if anyone... Good. Good. I think we're almost good to go. I think it's all... Yeah, the rest are header files, which we should have handled by now. And we don't need those. So, we should now be able to compile all C++. And we're going to now fail on some HLSL code that's generated by the material template. So, making good time. Almost done all the C++. Oh no, shit! I have to do velocity rendering.
I don't know what you like. So
ooh, I love this. Thank you. Cheers. Hopefully this makes me a little more entertaining. Now we're talking. I feel like I missed something. Where was it printing? I'll make sure I put it in the right location. This is the one I want. All right, good. Failing on hopefully the shader, right? Nope, failing on something else. All right, what did I miss? No, this is the shader. Internal error: more replace %s calls than %s in material template. So that's good. That means in material template, we just need to put that %s so that when we do printf, it's going to inject the right HLSL code in the materials created for every single material. All right, so where was that code? I want to make sure I've got this. You got to make sure you got the same order. So wherever we're printing, I'll search through the code with you in case one of you guys remembers which one it was. It's not that. It's not that. It's not that. Okay. It's got to be material.cpp. Got to be. Do material attribute reorder. As you can tell, I am using a trial version of SmartGit. I don't even use SmartGit at our office right now. Okay, and then here's must be where you print it. Nope. Where do you print it? I could do a symbol. Close. Nope. Okay, ruled out that file. It's definitely not light mess. It's definite cannot be the editor, but just in case. Okay, good. I'm not going crazy. Could be material expressions. This actually sounds right. So here's where it's compiling. And then where's it printing? Right here? Nope. You know what would help? I probably have it in the stack right now. This would be a lot easier to do. Alright, begin compile shader, get material shader. Here we go, perfect. I must, okay, this is good. How did I not see this one? Material translator, that's the most, oh, it was a header file. Okay, good. So let's kill that. We put it right after custom UV assignments, so it's a little out of order from what I was doing earlier, but screw it, right? Got a beer? We're gonna dive into material template. So this is fun. If you modify this file and you've got a lot of materials, be ready for some really long compile times. I'm lucky that I chose a vanilla version of Unreal Engine untouched with almost no assets in the project, just so I wouldn't have to live through too much of it. So let's find out where it's printing custom UV assignment. Custom UV. Custom UV, come on. Well, this will, oh, probably text cord. Maybe it's easier to search the other way around. So it's one of the first ones that's printed is for normal. Translate code chunk definitions, normal assignment. We'll use this as like a bookmark, and then so it's basically the second or third last one. Calc material inputs. This can't be it. Actually, it probably is. Initial calculations for normal, and then the normal. Okay. Get material, customized UVs. Thought I was typing that. Maybe I wasn't. All right, cool. If one, begin outpost. This is shader code. So if you, I'm gonna probably go into a simpler shader at some point and explain it. But this is the magic of how it computes values per vertex, like points in space, and then it rasterizes it, and then it uses the previously calculated values to output new pixel values. So like, what color is it? What color is rendered? So it's the building blocks of your computer screen. So we want what?
Gamer Boy Advanced asks, "Are you coding in C++?"
And C minus minus.
I don't know if he meant C++.
No, he's joking. He's clearly he's in the know. He's funny.
He is advanced. So. I like the name Game Boy Advance. Gamer Boy Advance.
That is a good one. All right, so get velocity. We need this. That's where we're going to plug in what gets outputted to the velocity pin. And we actually want the same here. We want it to be vertex parameters. I think we want vertex parameters. Correct. And we should be good. We don't need... That's for outputting to an array. We're good. All right. Oh, almost made a... Why is there a semicolon? It's... Okay, yeah. Is a semicolon needed? I guess we'll find out. It won't hurt to have one, I don't think. So now we should compile. What did I not answer? Rob didn't answer the question at C minus minus. Yeah. Canadian plus plus.
No. What's up, Wavy Grave?
So one thing you can't see is the loading screen on mine. So we'll bring up the matrix for some of you. Now it's compiling the shader. It's a good sign it hasn't crashed yet. Oh, some threads finished. Oh, that's a good sign. Hey, Romulo San, thanks for the follow.
Nice.
So Mythal, this is So the USF files are actually, they're mostly HLSL, so very similar to GLSL. And then, oh crap, okay. Failed to compile default material. Find out why it's failing. All right, let me answer your question before I dive into that one, because I'll have to go a little tunnel vision on that. It's HLSL, but it's formatted in a way that allows Epic to inject their own HLSL as well. So HLSL stands for High Level Shading Language. It's like DirectX's shader language. All right, now we're gonna have a fun task. So it's actually unable to compile world grid material. So I wonder why. Does it give me an error? Let's see. Oh no! Well, where all the windows go? This isn't what I'm used to. Alright, let's go back to output. Get velocity. Void functions cannot return a. Okay, so it's just I've made a mistake in my HLSL. Void functions can. Oh, did I say void? I've been running too much C++. So we're going to need a float too, because this is going to be a velocity in screen space. Right now we only need X and Y or U and V, whatever you want to consider it when it's in screen space. And now it should compile. Why is it doing this? All right, let me.
Did I make a mistake giving you that beer, Rob?
Yeah, now I'm just failing. No, it's gonna be fine. Yeah, 1 hour mark. This is actually pretty good.
Yeah, exactly.
I think the other changes compile super quick because they're going to be in velocity rendering, and actually that's the next step. And the other one is in velocity shader, which we can isolate to only compiling the version that's generated for that waterfall material we're going to play with. And then the other place, we'll load up everything that's going to be changed. So velocity shader, velocity rendering. And if you want to learn how velocity, the renderer, works, it's really, really informative. Actually, why did I think it was more informative than it is? Output to 2D velocity vector. Maybe I'm thinking of motion blur. Yes, I'm thinking of motion blur, where it shows all the different passes that occur. Find max velocity per 16 by 16 tile. Interesting. I wonder if that's why it's. Just as a heads up, it's going to look a little different in 4.15 than 4.12 because I did it in 4.12 where the motion blur post-processing shader was actually really, really simple. And then they changed it. They actually had like a .new, motion blur new that they turned on somewhere after 4.12, maybe 4.13, 4.15. That's thrown a bit of a wrench in this, but it'll look enough like what I just showed you at the start of the stream to get you started. And it would maybe take me a little bit of time to dive into why it looks a little different. Actually, it might have something to do with the fact that it's max velocity. Interesting. Okay, so we're actually in. And it's going to be compiling all the shaders. Luckily, it won't take too long. And this will be before we actually are doing anything. We've just basically done the plumbing. Actually, now is a good time for me to show you the plumbing. I'm going to show you the plumbing.
Do it.
Here is the material. And we now have, ta-da, velocity pen. And this has been set up by, this is Jake. What's his name? Jake from Bend, probably?
Yeah.
Jake from Bend's beautifully organized material. And I think here's where we grab the UV scrolling direction. And then we flip it, go in the opposite direction, and then transform it from tangent space to view space. So basically from UV space to, not UV, both kind of UV space to view space, screen space. And then, actually, I don't know, I'm not sure why we're normalizing it, because this would actually make it the same length no matter how far away you are from the camera. But maybe that looked better. I'll let Jake on chat explain that one. But and then this is just, it looks like it's doing something, but it's just multiplying it by some parameter. So we'll crank that up to show it out. And then it comes in here to make material attributes, breakout again to velocity. You saw there was that function, that breakout, that handles rewiring it there as well. This data flow environment is called Material Editor. All right, cool. So let's see if it's finished compiling. Almost 607, 567. So we're going to get a good look at what it looks like before we have the issue.
And Jake says no.
Oh shit, Jake's asking me a question I should have remembered from school. So I want to say it depends. I think it's got to be the center of the screen. Okay, so here is before we've got velocity buffer rendering. Okay, so if I get in really close, hopefully this is shown on the screen, but like you can see some pretty. This was like the ghosting that Jake came to me with and was like, "How do we fix this?" It was like, "Ooh, yeah, it looks a lot better in FXAA." So it's nothing wrong. His technique is incredible. It's simply that temporal is a little blurry, right? It's a blurry system, and it's very valuable. We go with it because it gives us a lot of things for free. It's going to give us better hair. Things just it looks pretty good, especially in still frames. In motion, I have some complaints about it, but we're resolving them one at a time. So now we've got this. Nothing's happening. Like, well, why is nothing happening? Okay, so let's look at. There's a way to visualize the motion vectors that are rendered to the velocity buffer. So the first thing we do is this: be like, oh shit. Okay, well everything's grayscale. It uses the color yellow when it's actually rendering it, and what this means is that it's just using the camera change, and then it's assuming all these things are static, and it's able to use like the previous camera's transformation and this frame's transformation to figure out like how far have these things moved. If you look very closely, you can see little arrows pointing. Hopefully it streams. Little arrows showing kind of where they're moving relative to the camera, and you can see very quickly the issue with this waterfall. There's no direction to it, so that explains why it's ghosting. There's no way for it to do any type of anti-ghosting. So we're going to solve that. The first thing we're going to do is make this yellow. And we did the first step that was required, which was we added that component to it. Not component. We added that Boolean flag to the static mesh component that said, always render velocity. So it's right here, always has velocity. That's set, but that's doing shit all right now. So what we need to do is, let's close this out. Did I change that material? I don't think I did. We're going to look back at static mesh renderer. Okay, so this will generate the proxy, which is like a super lightweight. Is it struct probably? No, class. Okay, it's a super lightweight class that's used to represent an object in the game, but in the rendering pipeline. So it's very, very quick read-write access. Whoa, that was close. Almost just fucked that up. Am I allowed to swear?
Yeah.
So let's.
Except you did it right when
my CEO looked through my window. So one thing we'll do is just here at the very end, if this is generating the proxy. Yeah. So right here, we're gonna have access to the component that we put that header file on. Why do I keep calling it that? We put that Boolean flag in. I'm just gonna shut up and code. So we go, B always has velocity. So this is already on these primitives. And we're going to go in component dot always has velocity. Hey, if you've got a good name, no reason, and outpost. Okay. So this will help. This will get us a lot of the way. So we go, I'll explain actually why we only had to do this as opposed to modifying velocity rendering. Because velocity rendering, it's actually, the fact that we've got a material that's masked is going to do a lot of the work for us. If we didn't do that, we'd actually have to modify these should cache functions and probably like is dynamic somewhere to say, hey, even if this thing is opaque, if it's got this flag or if it's got this custom velocity pin connected, we don't want to use the default velocity renderer, and we want to compile our own using the values that we're outputting to that material template. So I'm not going to do that for now, but if you do this and you wonder like, oh, why isn't my opaque or why isn't, well, mostly opaque. Why isn't my opaque object outputting velocity? That would explain it. You'd have to go in here and make sure it's not using the default one, which basically will ignore the code that we are about to add to the shader. So they have a lot. So they've got one for the pixel shader and the vertex shader, the hull shader and domain shader. And for now, we're just not going to worry about those. One thing we will worry about is maybe there's some artifacting that you'll see, and then I might come back and change the pixel format of the velocity buffer, which makes it more expensive, use up more bandwidth. But man, waterfalls are cool, so I'm going to be advocating that we use it, or we use like 8-bit precision per component, which is insane. All right, start. Oh, it's already started up. Okay, cool. So now still ugly mess of temporal blurring the shit out of it, but now, holy crap, it's yellow. It's like yellow. So now it's always rendering velocity. That's great. Only problem is it's rendering a velocity of 0. So it's not the correct velocity, but it's certainly a velocity. So how do we fix this? Well, now we're going to go into shader world. We are going to need velocity shader to call that function that we created on the material template. It was called get velocity, I believe. So we're going to do it in the vertex shader. I'll do a quick overview of how I have time. Shaders work. I think I kind of already explained. You got points in space. They're processed by the vertex shader. They go in. They go, oh, these things. There's some uniforms that exist that describe the state of the world. Here's your positions. Here's your vertex color. Here are things baked into the geometry. And I'm going to output values that then get interpolated across all these vertices. And then each of these vertices then gets rasterized, which means like gets like projected onto a 2D plane. And then it's like, okay, well, let's look at all these interpolated values and then calculate what the actual pixel should be using all of those as inputs. So first we're going to do is we're going to calculate what that velocity is per vertex. We don't need it to be as high fidelity as per pixel, and it's also simply more expensive if you do it per pixel. So first task, we're going to want to add it somewhere. We're going to need interpolators to allow the actual pixel shader to access it. So let's throw one in here. This is the vertex shader to pixel shaders. This is what's passed between the vertex shader to the pixel shader. Well, it's what's interpolated between the two. So if we go if1 begin outpost and if end outpost. Oh, by the way, we're hiring here at Outpost. So every time you see begin outpost, think, oh, Outpost is hiring. So we should check them out. So we only need float 2 for this, I believe, because it's going to be it's already basically in screen space as opposed to pack velocity A and C, which actually I think they're kind of a misnomer. I think they're positions and then a velocity is calculated from it. But let me reconfirm later. So we've got, let's call it custom velocity for now. And I believe this text coord is free. I believe it is. Merges may change that one day, but for now it's probably safe for us to do that. Now we've got it in the vertex shader to pixel shader. If you want to handle it for tessellation and let's just do it as well. Velocity shader to pixel shader. The one thing that's different is they've moved around some of the text coords here, but honestly, we're not even going to use tessellation, so this probably isn't that important. But I got the time, I think. I got 50 more minutes? Good.
Yeah, you're good.
To custom. Well, you don't know how much code I have left.
Well, you can go over.
Oh, well,
It's
I'm
only
not.
up to your time.
This is my challenge. I wanted to do it in a short period of time. So let's just take this text coord and I'll actually use this as kind of an identifier to let me know where I need to do things. Let's see, their interpolation. Pretty simple. All right, let's just use theirs. So we're going to call this macro interp.custom velocity. And This is the vertex shader to the pixel shader. This is where the, this one's pretty straightforward. Just gonna assign it directly.
Internal static void wants to know. That's a good coding name there.
Shit.
He wants to know, are you sending in a noise map for the velocity?
I am not sending in a noise map for the velocity, no. But, I mean, Epic might be.
Yeah.
So I didn't create the velocity buffer. I'm basically just allowing materials to render to the velocity buffer. And before, they basically had just their own material velocity that they would send based on changes in kind of the mesh's position. So it's for things like waterfalls for UV scrolling. All right. Oh, that was a mistake. Okay, before you write too much shader code, one thing that's really important for you to do is r.shader development mode. Set that to 1, and that'll allow you to make mistakes to your shader code. Then you won't crash the entire editor. So, because what would happen is, as I'm changing velocity shader, I don't want to compile all of the shaders that exist in memory right now. I only want to compile, or that are even referenced. I want to only compile the one that I'm playing with. So let's fail fast and fail early. So that would have failed. So custom velocity. That's good. So we've handled interpolation. Now let's handle it in the vertex shader. Must be close. Oh man, instant stereo. I don't. Okay, good. My eyes are just looking in the wrong direction. This is correct. Okay. So what we're gonna do? Yeah, let's put it here. Is there an if statement in this? What is it branching around? Okay, nothing's guarding it from being run. We can just run it in here. So if one begin outpost, and we're going to call that material template function we created, which I think is called. Let's look back again. Material template. Get velocity. Probably should be get custom velocity, but I don't want to change. Is there a header file for it? Oh, I could change it now. Oh, no, I'd have to compile every shader. Okay, choose better names than me if you do this yourself. So what we're going to do is simply go, let's grab that data, and we can put it directly into custom velocity. So we need get velocity, and we need the velocity parameters. What are these? Vertex parameters, velocity parameters. That should be good. Yep. This is a float 2, right? I set that correctly to float 2. Float 2, float 2. We're going to be good. You got a question?
Well, internal static void seems to think you made a mistake.
Oh, I did.
Endif,
oh, I totally did. Good fucking eye. Good eye.
So thanks for watching us.
Well, that's why I put in the that's why I put in the shader development mode so that I. That's a good eye. Yeah, that would have been caught by the editor, but it would have been a pain in the ass. So that's good. So that's going to now be interpolated across every vertex, whatever velocity Jake decides to put in that material node, and then in the pixel shader. For now, let's just add it. We're going to change this in a second, but encode velocity to texture. That velocity is already in screen space. Let's just throw it on top of it. Okay. I'm going to change all this later for some artifacting that we see, but definitely the easiest way to kind of show us some progress. So velocity, let's add the custom velocity. All right, let's see if I missed any other, of them. All right, so we're not going to see anything yet. We'll just see if it compiles. Ah, shit, didn't mean to open that one. And let's at least do this so I know I'm not messing anything up. And again, this is not going to be a great reveal because I don't think this does anything yet. It's literally just going to, look what I do. I just like press up or down and then apply, and then it'll just compile that one shader. Sorry, it'll compile all shaders associated with this material. So when people think that like, oh, material is actually like a rubric or like guidelines for creating a whole bunch of different shaders. That's why you see like 80 shaders created every time you modify a material. That's a really good sign. So no crashing means that we've at least written logic. We've written code with correct syntax. That's what it means. Doesn't mean it's correct yet, but now let's see. Yeah, let me make sure it's not doing anything yet. Oh wait, no, it would be doing something now. Sorry. Yes. So now it's close. It's getting there. There's some volume to it. It looks a little like there's motion blur. If we go in here. Oh. Almost. What is going on with the... That's bizarre. It's not going the right way, but it's certainly outputting something. So I believe that means that I've fucked something up. So that's good for me to know. Let's go back to the custom velocity. This is before we encode it. So this is correct. This should be correct. Hold on. Well, it's looking better than it did. We can. Okay, here's how we can debug this.
Thanks for the follow, Heisenberg.
Thanks for the follow. Woo!
We were a little late, but
never late. Okay, so you can always see what HLSL code is generated using window, HLSL code. And I wish the editor in here was a little nicer, but instead, let's close all that. No, I don't care. I don't care. All right. Get custom velocity. Get velocity. All right, so it's certainly embedding the code that Jake wrote into this. So that's good. I wonder if it's that extra semicolon I added. Shit, that would suck. So that's good. So float to get velocity. Hey, hi, Trick Pekka. Thanks for the follow, man.
Good eye.
All right. So I hope it's not just that the materials changed. Let's look at the code. This is the most fun you can have, is when you have to. Oh wait, get velocity. That's right. Get vertex parameters. We'll figure it out. Factory interpolants, custom velocity. I am writing custom, right? Float 2.
Jake asks if the values are transposed. U and V look flipped, he says.
Maybe. So we're not doing tessellation, so it's not in this domain shader shit. It's got to be here. O.interps.custom velocity. Interpolant. Okay, no, it's if one output.interps.custom velocity equals get velocity vertex parameters. It doesn't even need vertex parameters. It's clearly. You know what? Maybe I have to compile every other shader. I can't imagine that being the case. Are there multiple materials on that static mesh, maybe? Main pixel shader. What do we try just stomping? Try stomping for now and see if it changes that view. It doesn't look like they're in... Oh, wait. That is totally correct. So there's something else going on. Hold on. I don't want to undo. This was right. Okay. This is good. This is good. So, oh, what the? It's like at certain angles. Am I going crazy? This looks correct, right? That's the direction water flows.
Yeah. Looks right to me.
And then everything else goes to shit. Ah, it might be in the way that it's encoded. Hold on. I am going to try just stomping. And let's see if... Come on. Come on. Oh, interesting. I really screwed that one up. Velocity equals output.custom velocity. That's bizarre. So I actually just made this change. Does that mean we're not actually getting anything? Custom. That's correct. Okay, one more time. Sorry for the things were going too well before. It was inevitable that I had a hitch. What the hell? Yeah, it feels like it's not being... Could the material have been changed on me? No way. No way. Let's throw it on something that's like flat or something, or... Throw it on a cylinder. See what just happens. Oh, was I putting it on the wrong one? Is it default or white water? Which one's got the... Alright, let's make that movable and always has velocity. Oh, wrong one. Shit. This thing. Well, that can't be right. Yeah, there's gotta be. I'm missing something. Okay. Looks incredible from one angle. No. Maybe I'm not taking rotations into account. Hold on. No, there's something so wrong with that. Velocity. I'm going to try one thing that's crazy. I'm going to try something absolutely insane. No way, that can't make sense. What am I doing wrong? I'm the right shader. All right, anyone got any ideas of what I missed along the way? I can look at...
I was going to say, ask the viewers.
Hey, viewers, what's up? I'm going to look at my log. I actually have my changes in a previous version. That is bizarre.
Etienne and Low asks, is this shader available for download anywhere on Unreal Marketplace?
Yeah, it is not, unfortunately. But it's also not a material, right? It's a... Oh, you're talking about the material before this approach goes in? No, it's made by Jake. Let's look at our history. I did the change to our dev upgrade branch. So... Wait, dev branches, dev upgrade.
Do we normalize the values as an internal static void?
I mean, the material itself is normalizing the values, but... Oh, that's a good test. Let's create a new material. Let's see if... No offense to Jake and the material. I want to just... I know it's my fault. I've made a mistake, but I want a better test case. So if I have a material that's just like always down velocity material. That's great. All right. We're going to add... The other thing we're going to do is, let's just compile everything for now. All right, that's a lot more shaders it has to compile, but it sure would be worth it if it helps me track it down. All right, I can answer lots of questions now while it's doing this. More beer. I like Bobster. Bobster 3D. Alright, that was a bit of a Hail Mary, but maybe it'll work. Okay, and while that's going on, let's just let's always output something like down or some shit. Or to the, let's go to the right. And how big does this value need? Let's make it a parameter maybe. Oh, did I just save a material while I'm compiling materials? That is such an amateur move on my part. No, it's gonna be fine. While that's going down, let me go. While it's compiling, let's look at. You get a sneak peek into the SOS code base. Dev upgrade, engine, velocity. This is probably the one. Let's look at the shader code in particular. Oh, it's probably a precision issue. I think I've been treating everything as half 2, and then some places as float 2. So let's. Shit, I wish I hadn't been compiled. That would have saved a lot of time. All right, so let's go back to where we have all our velocity. Oh man. That explains it. So let's make this. It is half 2, right? Yeah, hold on. That's not the right one. So where do I need to change it to half? So in the template itself, return half 2, which I'm certain right now I'm doing float 2. And then.
Oh, Etienne and Lass, can we mention the apps we're using besides Unreal?
In terms of, I'm using Visual Studio. Yeah.
What are you writing?
I'm writing in C++.
Well, yeah. Oh.
Right.
What is the? Yeah.
All right, this makes so much more sense. It's using it's using 32 bits when it should be using 16. So that's the issue. So we got to go around and fix. This can continue being a custom velocity, but the biggest one is here where we're getting get velocity. So in the template, this needs to be changed to half 2. Oh, okay. That actually might get us the whole way. So let's get the game back up, and let's recompile this guy with this view up. That explains why, like, one of the directions seemed like it was working. And then apply. Oh no, close. Close but no cigar. Okay. Let's see where the other places were that I needed to do. Float 2. Okay. Text chord 8, text chord 9. I named it something differently, but that's not going to do anything. Custom velocity. Additional. Okay. So maybe this is branching. Oh. No, I can't imagine that being the case. And that was the same change. Okay. So we're going to just make a few changes. Let's also just get rid of this extra one. And leave that there for now. In here, we're going to just bring it up a level. I don't know why that would matter, but just in case. All right, let's go to an angle where things are broken. It seems like it's always just going away from the center. So come on. Ah, okay. Hold on. Let's throw one of these materials that we were playing with just for a test. So it's in there now. And then here, let's set this to thing needs to always be movable. Always has velocity. And let's start playing with this guy. Okay, this will help us debug. So we'll try one channel at a time. So we only get the first two. So this should... Does it have to compile every time?
I don't know if I'm behind here. Epic Arn said the idea with the always down material was a good one. Try that.
Yeah, so I'm back to that.
Okay, cool.
Interesting. So maybe I got the wrong... Holy crap. What the? Is it compiling? It can't be. That can't be it. Oh, okay. Okay. I'm a freaking moron. I have not finished. I'm jumping way ahead of the gun. We're not even close to being done this. Like not even close. I don't know. Okay, I'm a fool. So let's fix this. Let's fix the visualizer. Let's do that first. My bad. I wasted everyone's time. Okay, so we go post process. So everything actually is working for that velocity shader. The issue is that we have not updated the actual post process material. Sorry, the motion blur post process. So let's go to visualize and make sure that these are correct. So the problem is this is really. Oh, wait a second. It is... I am outputting to the same channels. Just those two. So why aren't these two outputting anything? Oh, interesting. Is it only... God damn it. Alright. I'm confused why this is outputting anything and this one's... Oh, okay. This one needs to be... This needs to be masked. Okay. So let's go to masked. And then let's always output const 1 or something.
Does the water have any form of collision as FDN low?
No, it does not. I have an idea. This should continue rendering it. Why aren't you rendering to the velocity? Movable always has velocity. And what is the clipping value? Dithered. Okay, if we do... Maybe this will force it to... Apparently not. I need to force this thing to always render for me to debug this. So the problem is when you go to masked, it's smart enough to know that the mask is always going to output to a value that doesn't call it. So let's just use something crazy like sign between 0 and 1, then plus. Let's do world X position. Can't break. Can't go from 4 to 3. You're right. Break 3. Should at least confuse the. What the? Well, now I'm just confused. Hold on. Did I put the right material on it? Yeah, I did. Okay. Oh, forcing it to two-sided, I think, will help. And then let's just get rid of this. Ugh. Come on, render. Let's see if there's anything else I can do. I need to... I just want to see some movement. Okay, there we go. Why was... Is it clamping those values? What the heck? Okay, so that's correct. That looks like it's the right direction. That's great. So let's make sure it's the right ones doing it. All right, good sign. Let's continue playing with that. All right, that's totally right. Why? It might just be the material, the waterfall material. Do negative numbers work? Yep, negative numbers work. Those all work. What the heck? Okay. Well, that's a good start. Maybe it's the rotation. So if we apply that material to all these things, well, no, but we can see it from every direction. So let's do -1, -1. Every direction is. That's totally correct. Maybe that material did change. That'd be funny. Yeah, that is correct. Okay. So, without further ado, we can go back to figuring out why the waterfall. Why does the waterfall have such a unique one? Interesting. Hold on. Maybe it's too big? Maybe it's blowing out? Okay, let's try something. Let's divide this by... Let's go like 0.4. Oh my gosh, I'm a freaking moron. I was going too big for the... I was just blowing them out to be too big. Okay, so they were literally just like losing precision. Okay, I wasted so much of your time. It was always working. Damn it. Okay, that's good. So, actually, why are you... Okay, back to static. Stop rendering. Okay, this is good. So this is the direction you'd kind of expect to see, right? And there you go. Okay, so it's outputting the velocity. Now you can see a horrible problem, which is the banding, and that's because the basically anti-ghosting of temporal is trying to fix motion blur for me. But in reality, I don't want temporal to do anything there. So because I only have 22 minutes left, I'm going to fix this banding issue instead of the other issue I was hoping I had time for was this. It's like frame rate dependent. So if you go like really fast, it's too blurry. If you go to 30, you start to lose it. But that's kind of a small thing, and it can be done really quickly. You just need to scale the velocity that's coming in by that amount. And that's actually why the velocity was so high on this asset. And that's because I was multiplying by the delta between frames. So multiplying something really big by something really small made it much smaller, and now we're just multiplying something really big by nothing, and it's so now it's getting there. Let's fix that banding, okay? Let's do it. So this is fun. Let's go. This is where you need to do something that's going to maybe scare some of you, and it seems it's not that complicated, but you've got these pixel formats, and here we've created a velocity buffer with the right here. So this set render target output format, this is preparing it to render all the velocity vectors into this render target, and it's using 32 bits, 16 bits for one component, 16 bits for the other, and then it's encoded in values between -2 and 2. But for now, for the sake of actually getting this done in the next 20 minutes, which was a challenge I put on myself, I am going to upgrade this to a much higher memory usage. You're going to double it basically, and use one that has another 2 16-bit channels for blue and alpha. So let's grab this is the one. So basically replace all of instances of this with that. And because of time, and because I think we're not going to get new streamers who would get confused midway through, I'm just going to replace them all with this. Not even put the if things everywhere. So this will surely speed things up. Don't do this unless you're willing to take on the extra bandwidth and extra memory associated with it. It's like 8 megs or something for that. So that's good. Let's exit out and save these, I guess. Yeah, save. And let's recompile. That's I think the last C++ change we'll make. And it won't get us the full way, but it'll get us halfway there. Because we actually need to start using those other channels. What we're going to do is basically split off how motion blur samples its velocity from the velocity. Uh-oh. I hate it when it does it. All right. I'm out of beer now. I'm back onto water.
Uh-oh. You want another one? Or is
I don't know.
a bad idea? Because I can grab you another one. You got 20 more minutes.
I got... Actually, if I want to make this in 20 minutes, I might need a beer. That'd be great, thanks. I love my job. I love my job. All right, so this is good. It's compiling. It's running. Here we go. What you'll actually see is no change once it finishes. So in the meantime, let's bring back our velocity render. Velocity rendering, velocity shader. And instead of outputting to these channels, X, Y, we're going to output to these unused channels. They're outputting clear color, but they're not outputting anywhere because they're using only 32 bits. So the 16 bits are the X and the Y. And we're going to just throw in if1, begin outpost, and if end outpost. And then for now, and there's many ways we could do this, but I think we're going to just... you can add them here, or you can add them in post. Let's just do outcolor dot XYZ. Oh, I went the wrong way. Hold on. Oh yeah, that's right. ZW equals depends on if you want to code it. Let's just do this for now. We'll add them together in the velocity. Sorry, the motion blur. Because then we can do some other things there. So that's good.
So now everyone in the office wants to stream so that they get me to bring them beers.
Dude, I have the best job ever. Okay, so that's good. We're now outputting to the wrong channels. That's right. XY outcolor.zw. That's red, green, blue, alpha, custom velocity. Oh no, that was a mistake. We need to encode it as well. And it just normalizes it between -2 and 2, and then like offsets it by a little bit so that you can do like a check, like a branch on whether or not it's like 0.499999999 or something. All right, and it's compiling shaders right now. It's a good sign that it hasn't crashed. And let's go to the post-process motion blur. And this will be, yeah, I think I'll get this done in the next 16 minutes. So there are two parts where this we're basically going to break it by componentizing it like that. We're going to need to go to, let's do visualize, because that's the first place we're going to look. And it's also the easiest. In here, we sample the velocity at the center. Interesting. Okay, velocity tile at center. I'm trying to think if I need to do something with opaque at tile center. It's gonna sample .x. I think it should be fine just to do it here. So instead, so we decode here. We're gonna actually need to decode ZW as well and add it to it. So if we go F1, begin outpost. It's getting hot in here or what? we're going to add... Oh, actually, what we really need to do is replace the whole thing. Because we actually want to sample and then use the same one. So, like, it's going to be all 4 channels are relevant now. We're going to go velocity, pixel. I don't know. It might be poorly named. Don't care. We only got a little bit of time left. Okay. And then we can decode from the red and green channels, and then blue and alpha. ZW, and we add it to it. Actually, let's leave it like that for now. You got a question?
I don't know. To wave ask.
The answer's
where
4.
Is all the color in the text?
Sorry?
Where is all the color in the text?
Oh, in the IDE? That's a good question. I don't use... so we switch between C++ and HLSL, and I guess it's not detecting that it's HLSL. I'm not actually used to using colorized HLSL. It's pretty low level, so I feel more badass when it's black and white. So that's good. I think this is going to get us our visualizer back. Because right now, before I compile it, it's going to go... If we just compile this guy, again, we're going to lose, hopefully. Can't believe I said hopefully we lose.
Thanks for the follow, Orange Crust.
Thanks for the follow, Orange Crust. Woo! First thing we're going to do, just force this to... I put it in shader development mode, right?
I got a spam phone call and I just yelled, "Thanks for the follow, Orange Crust," into that spam.
Nice. That's what they deserve. Booyah. All right, cool. That's good. So now we've lost all of the motion blur that we had because we put it into a channel we're not referencing. Because I haven't compiled the post-processing shader yet. And I'm about to. So if I do show motion blur, nothing's happening. But if we go Control-Shift, we're going to recompile every single shader. Hopefully it's not a big one. If it is, I'll sing a song for you or something. It's looking like it's going to be a big one because it's taken a while. Let me look at the output. View output. Okay. Compiling 7 global shaders. Compiling a whole bunch of shit. Yeah, it might take a bit of time. Oh no, that's pretty good. Oh no, that's bad. 33,000. Let's play a game. Let's read some of your messages while we wait for these to compile.
Nice. Rob Weiss is always keen to...
Hey, Rob Weiss, how you doing? Dude, you were so fun to play with. Did you get to see the most recent episode we posted where you and I and Katie Rue, we all team up and we destroyed? Eric P3, good to see you here as well. Man. Sending out an SOS. I'm not a good singer, sorry. But
better than some of us in this room.
We do like to go to karaoke a lot and sing that song. We also, what are the other songs that we sing? Message in a bottle. Oh wait, that's the same song.
Yes.
There's no, it's the Rihanna song we like. All right. Yeah, there's the video that Dash Reindeer Micah just posted. If you want to see, that was a great game. That was so much fun. It's not just because I won. We're getting close. We're 2/3 of the way done with our compiling shaders. I think we're going to finish it just in time. Maybe I'll even have time to do the thing I wanted to do, which was make it frame rate independent.
Heather says the ABBA one. Is that what you guys sing?
I'm trying to remember that one. I used to be a big Mamma Mia fan when I was in high school. That's embarrassing. Crap.
Why did you say that on stream?
I used to do like theater and shit.
Oh, right. Yeah. Well.
Those were dark days. Those were dark days. All right. We're so close. So close. And so hopefully what we see is correct. Okay. So now we've got the correct velocity again for these. But it's actually going to be broken in the game. So it's back to Ghosty McGhosterson, the waterfall. So that's because we haven't finished off both pixel shaders. We just did visualize. But it's pretty easy to do the rest. I think all we need to do is handle it in the flatten phase, because that's where we kind of gather all the pixel samples and then combine them. So let's go to, it's actually its own shader called flatten, post-process velocity flatten. And then here we sample something. Scattered min-max. This is, ooh, I don't want to play with, what does CS stand for? Okay, here's the pixel shader. This has got to be it. So anywhere it's decoding velocity is where we'll want to replace. And this is pretty simple. I may need to do a check on not just .x, but what we'll do is F1, begin outpost, and if n depth. Okay, so we don't want to change that. We're actually going to we're going to basically do what we did in the motion blur, which was, crap, we're going to make one more difference. Okay, so first thing we do is velocity pixel, or whatever we name it. And post-process input, this is it. Okay, now we're going to take all four components. We're going to call this the velocity pixel, assign that. And then from there, we need to decode both velocities. So first, it grabs this velocity, then it does that, and then we're going to want to grab the remaining two. So if one, begin outpost, else. Actually, we don't need an else. I don't think we need an else. We don't need an else. Okay, and then we can add to that velocity. So yeah, the one thing that I might be, because this is all new code to me, I have not written in Unreal Engine 4.15, other than an upgrade to 4.14, so all this is a little new. Might be screwing some stuff up, but I think I can just do this. Grab the other two components, x, y, z, w. That should add the velocity from the other two channels, which was the customized velocity, which we only apply to post-process velocity. We do not, which gets run through motion blur actually, and we are not going to make it. We're not going to make change to temporal, because basically that blur, that ghosting we were seeing, is just is too much. It might actually make sense to split those two channels into decidedly the temporal motion velocity and then the motion blur velocity, and then because then you could actually output accurate velocities to one of the two channels, and then the kind of fun motion blurry ones to the other two. And I think that's how you would get kind of the best of both worlds, where you'd get anti-ghosting and then the motion blur that you want on top. So that should be good. I think if we step back for a grand reveal, 7 minutes to spare. Booyah! Okay.
Nice.
So it's close. It's not as perfect as I think. I still would have to come back to it and figure out what the difference is between the one in 4.12 that we have working really well and this one. But it's clearly blurring in the right direction. Again, the one thing it doesn't have is frame rate independence, but I just don't have time for that right now. This gets you most of the way there. I think what I'm maybe missing is, if I look really carefully, you might not see it on the stream, but there's like every so often little pockets of non-blur, which makes me feel like I may be missing something. If like maybe because it's masked, it's sampling pixels that then are like, oh, there's no velocity being outputted here, and that like overrides it somehow. But I like how that looks. We're gonna take a quick look. We're gonna end with kind of the final reveal for those who haven't seen it inside of our own game, which I think is a little
exciting.
It's a little better quality than the 4.15. Actually makes me a little. I mean, this looks fine. It looks good, but especially if we compare the two, if we turn motion blur off, so go motion blur dot amount. If we change this to 0, like that's quite a bit different between the two. And of course, we can go crazy with the amount of motion blur. So if I go into this guy And then we change this from motion blur far to like, let's go freaking crazy. It's like, okay, that's starting to look a bit more like what we have in our game. But still want to go to the other game. I really like how it handles blurring around the edges compared to non-motion blur. And then one other thing we can look at is, this might not be the best example, but because these things are masked, and I do realize that we're eating the cost of rendering for the velocity buffer, but like the pixel shader is actually relatively cheap compared to if we had done this in velocity. If we had done this with translucency, it'd be like white just about everywhere you see. So let's see if the game's finished loading. It's still going. Oh, wrong beer. This is without it, sorry. There we go, back to pretty. I love how it actually looks like it's translucent. I've been thinking about using this technique for fire as well. That might be... Not that there's certainly not gonna be anything like that in our game. It's for something else. It's for fun. While it's loading, I want to take this opportunity also to remind everybody that we are hiring a lot of engineers right now. We are very understaffed and overworked. It'd be great to have some companions joining us and doing some badass things. If you haven't checked out SOS, our game, be sure to do that. It's a very, very unique take on survival games. It's a much more social. It's steeped in social. And every action has consequences, including how you interact with people. As I'm sure a lot of the streamers here, like Eric and Heather, can attest to. All right, so we're back into Unreal Engine for 12. Perfect. This is going to be ending right at the right time. Now let me get rid of this guy.
Looks like everything's coming up wrong.
I know. It's just that 15-minute period where I was like, just had the wrong parameter put in the material. All right. There it is. There's the game. This looks like it's in a cave or some shit. Whoa. Okay. This is the island of Lacuna. Calls out quite a bit if you are up in the air, but here's there it is. There's the beautiful result. Obviously, I think it looks a lot better in 412. And honestly, when we go to 415, I'll definitely put more effort other than just 2 hours on a Thursday to make it look a little better. But here's before and after. The one difference is, of course, there's like a bit of dithering here. And then this one. Oh my gosh. Oh my gosh. Good job, Jake. So I'll take the next few minutes, maybe just answer questions as we. Yeah. So now that I'm done,
it's all working.
It was all working in 415. I'm maybe a little crazy for deciding to do that. Just jump into engine code in a live stream. But thank you so much, Chemical Placebo. If you've got any questions right now, I'm actually looking at the chat finally instead of a bunch of code. So if you've got any questions, any concerns, any complaints about me, be sure to just use the next few minutes to do so. Definitely. Hey. It's like, Rob's always drinking. I think, that's...
Yeah, if you guys don't have any
questions, I might...
We timed this perfectly. This was exactly how we planned it.
Oh, Eric's got a question.
Nice.
Always got an answer for you, Eric. You're my favorite contestant on SOS, man. What kind of beer is that? This beer is the Shock Top, the Belgian White, and it's beautiful. But it's not as great as the. How applicable would the phrase "Don't quit your day job" apply to people who only work at night?
Oh,
interesting question.
That's a brain teaser right there. Oh, and Eric also asked a brain teaser.
Do snakes have long tails or long necks? All right, let's get the easy one out of the way first. Eric's is a little easier. Mm-hmm. They have long tails. I think they have long bodies almost. Yeah. I don't even know how much of it's a neck. A neck needs to have kind of insets, right? Where
Yeah.
it's like gets a little
It's
smaller.
actually not a neck.
I don't think there's a single neck
Go in.
on. Hey, Trenton's here. Good to see you, buddy. How applicable would the let me think about this one. Don't quit your day job. Apply to people who only work at night. Oh, it's not a serious question. It's a joke. It just went over my head. Is that what happened?
It is a joke.
I would say that's got to be great. If you don't have a day job, then you should just continue on and continue being badass. What is the performance difference measured? So it's basically the same delta of light. We can do a run right now. So it's the cost of motion blur post processing and velocity of having an extra draw call of the to the velocity buffer. So like right now we'll do a.
Yeah, Eddie, and if you
that one's
if you
expensive.
like that
20 milliseconds.
That water, you should check out our stream from last week where Jake from Ben shows you how he made it.
And then let's turn off motion blur on these guys. Make it static. They won't render anymore. It's not cheap. But it's also it'll be a cost based on the number of pixels, right? So when you're up close to I'll give you a good comparison. Hold on, let me bring it back. Make sure I got them right. 2, 3. And also, Jake could help optimize these for me a little more by making more opaque pixels in the material. So hint, hint. No, it's fine. It's gonna be fine as it is. Waterfalls are known for being kind of more expensive. So. Oh, wait a second. I was wrong. You're going to love this. Here's the delta in cost. I'll show you where the cost difference is. All right, so the difference in cost, this is before. This is without custom velocity rendering, 14.8 milliseconds. And it's 15.0 milliseconds. I ran it about 4 or 5 times to get a good average. So the increased cost is obviously in post-processing. And it should be in, let's do, temporal, that doesn't make sense. It's actually pretty cheap. Holy crap. Where is it? Where's that 0.3 coming from? Motion blur. Yeah, so basically 0.4 milliseconds. Well, actually, hold on. What was the total cost again? 14.8 versus 15.02. Let's see what this will be a better way. Let's do this. So before. And then we can also do velocity because there won't be motion blur. Okay. So the motion blur setup is 0.16. 0.16 for the combine is 0.3. It's like basically 0.3 in a bit. And it's a bit more for when you've got that big object that you're rendering, that's outputting a whole bunch of velocity vectors. So the total cost difference is, okay, it's not bad at all. It's 0.3 versus 0.5. You're losing maybe 0.2 milliseconds, 0.3 milliseconds. Totally worth it for a full screen waterfall. And then, of course, well, this isn't counting the increased buffer, right? The velocity buffer is a bigger size, so that might be a bigger issue, and also memory constraints. But in terms of actually rendering those in the custom velocity rendering buffer, that's pretty cheap. Custom, actually, where is? Yep. All right, not bad. Cool. Does that answer your question? Is there some kind of LOD setup for it? So yeah, actually, the LODs are kind of handled by the fact that it just turns off at certain distances. So like, oh, it stops. But because it's also a cost that's per pixel, I would say that the best LOD system for it is the fact that it gets smaller as you get farther away. And we always have motion blur on, so we're always eating that cost. It's totally worth it. It makes some Really sexy waterfalls. All right. Any other questions that I missed? Others that are not jokes.
No, they're like all jokes now.
Why do you use the phrase pair of pants to describe a single... Okay, they're just screwing with me.
Etienne asks, is there some kind of...
Oh, I answered that one. Yeah.
Setup for it?
That's the one thing I answered.
Okay.
Will the stream be stored? Absolutely. We'll send you that stream. You can skip. There's about 15 minutes. We'll mark that you should skip through where I was spinning some wheels for a while, but I think we're good. I think we're gonna end the day.
We are great.
We're good.
I posted all the links I wanted to post.
Sweet.
So just when you're finally done,
Press
don't
that.
Stop it.
Just
Go
at
to
end
the
show.
on, yeah.
All right. Thank you so much.
Yes, to say thanks again.
Okay, Dad. Thank you so much. It's been a blast. I did not think I'd have so much fun just coding in front of a webcam for a while, but I'm sure I'll do it again when I find something else to tear apart in the Unreal Engine. All right. Cheers.
Yeah,
have a
thanks,
good
everyone.
one. And thanks
Awesome.
again, Micah, for being my sidekick.
Yep.
End of show, right?